So welcome everybody to this session. As I said, this is my very first Zoom session, running a Zoom meeting. So wish me luck. But today I want to take you through how you're going to do your observations with LCO. And I've got a couple of example stars that we're going to look at. And we're going to go from A to Z on how to get your observations going. And I'm probably going to spend a little bit of time talking about how you measure your double stars using a program called Astro Image J. All right. So I'm going to share my screen if that's okay. Now I'll need your feedback if that'd be great. So all right. Can people see my computer desktop? It should have a whole lot of
Yep, we see
icons.
it.
Yep,
Yep, we see
okay,
it
and it's
now.
got the dragons of Ara present there.
Absolutely.
All right. So, everybody else, can you, if everybody else see it? Adriana, Maya, can you see it?
Yeah, yeah, I can see
Okay.
it.
All right. Okay. All right, so what I'm going to do is I'm going to show you how to take pictures using the Los Compras Observatory network. And as I said, I've got a couple of objects that we're going to look at. Now, Dunlop 5 is one that we've talked about in class. It's a binary star system located in Eridanus, the river. It's a southern constellation. Now, the multiple star that we have been talking about before, that's not currently visible. It's in Carina, and it's the way it is in October. It's up in the sky when the sun's up, so we can't see it. But I have got another multiple star here called HJ 1834 that we're going to have a look at. Okay, so let's go ahead. First thing you should do is just open up Google and then go to Stellar Doppy. And Stellar Doppy is a very useful program. So we're going to go to Dunlop 5. And here's I'm just going to move this out the way. Okay. So here we've got all the details of Dunlop 5. We know that it's a binary star. It's got an orbit here in the 6 orbital catalogue. And we want to take some pictures of it. So how do we do that? All right. Useful information here is that you've got the magnitudes of the primary and the secondary, and you have the RA index of the star. So put this up first. The next thing you're going to do is go to Los Compras Observatory, the observation portal. Now it'll ask you to log in, and you should have a username and password. I've already logged in, and it'll come up with this screen for you here. And you can actually see that I've taken some pictures of Dunlop 5, the binary star, and also the multiple star HJ1834 for this session. Okay. So the first thing you do is you want to go to Submit Observation. And then you give your observation a name. I usually like, oh, and let me just preface by saying that there's a video on how to use Los Combros in the classroom notes. So I'm showing you what I do. It works. You can vary the technique if you like, but this is one that has worked for me quite well. All right. Sorry, is everybody still there? Tom, can you be like speaker and say
Yep.
yes?
Yep, I
Okay.
hear you. You're fine.
Okay. So I usually like requesting it with my initials because, sorry, it just helps you find things later on because you can search for things. And if I search for RJ, then it'll pick up all my objects. So we're going to look at Dunlop 5. Okay. The next thing you want to do is click STEM. So this is the Boyce Astro account for LCO. So you need to tick that. Leave mode, leave IPP factor, leave accessibility threshold, configuration repeats, optimization time and mosaic. Leave these other things as they are. Don't worry about that. Now we're getting down to exposure count. Um, you can vary the exposure number. I think Pat usually says minimum of 12 images. I actually go for 20. And it's best to do it over a couple of nights because seeing one night might be better than the other night. So first of all, I'm going to take 20 images or 20 exposures. Now, I'll come back to exposure time in a moment. Filter. Now, there's a section in the class notes about using filters, and sometimes filters can be used to enhance the separation between binary stars. For our purposes, I find that a Bessel V filter, a visual filter, works just fine. So I would suggest you start with a Bessel V. Now, the exposure time is how long do I get the camera to do an exposure to get a useful picture that I can analyze. And what they have here is an exposure time calculator, which is very useful. So click on that. And then you've got these fields to fill in. Go back to your stellar Doppy, and you know that the primary star is 5.78 and the secondary star is 5.90, and they're pretty similar. Pick the brightest star. Sorry, let me just go to, yeah, 5.78. Now we know that we're using a Bessel V filter. And we want the air mass to be less than 1.6. So air mass is how much air you're looking through, how much of the atmosphere are you looking at. So if you're looking straight up to zenith, the air mass is 1. If you're looking horizontally, then it's a much greater amount than 1. And wait a sec, I think I might have something. Let me just mute. I think just here you can see this. Okay. Let me just magnify that. Hopefully you can see that. So here you've got an air mass of 1 for the sun. But as you go across here, you're looking through thicker parts of the atmosphere. And really, for your observation, you want to have an air mass less than about 1.6, which is about 48.2 degrees away from the zenith. I mean, 2 is getting a bit, you probably don't want to go to 2. If you have to, you have to. But I would try and keep the air mass certainly less than 1.6 and even lower than that if you can. So let me just close that. All right. So now the moon phase is not that critical at the moment. It's going on its last quarter moon going on new. So I'm just going to leave it at last quarter. Then you put in an exposure time. Just guess. It's a bright star, so I think the exposure time will be, let's say 0.5 seconds. Okay, half a second. And we press calculate. Whoa. And we get this red flag coming up here, this PKDN value, and it says saturation may occur. Consider reducing the exposure or defocusing the telescope. What it's telling you is that at that exposure, you're going to saturate the star images, and that's something you don't want to do. You want to have the stars unsaturated so you can do differential measurements of brightness between stars. And the way to get around this is just reduce the exposure. And so let's go down to 0.3. Calculate. No, still too high. All right, let's go down to 0.2. Calculate. Well, that's better. It's under 40,000. Try and keep it under 40,000. And we can squeeze it up a bit more. Excuse me. Let's try 0.26. And we're up to 37,000. We're under 40,000 and we're not saturating the image. So 0.26 seconds will work for our star. Now, if we look at the secondary star, 5.90, calculate. Well, we've still got 33,000, so it's a pretty good figure and a pretty good signal to noise ratio. So it looks like 0.26 seconds is going to work for us. So let's go here and we're going to put in 0.26 seconds. That's going to give us a good image where the stars are not saturated. Okay, we're going to take 20 pictures here at 0.26 seconds and we're using a Bessel V filter. And now we have to tell it what our target is. So our target is Dunlop 5. That's the WDS identifier code for it. You can put in numbers if you like as well, but I usually just put Dunlop 5. Now you need to put the right ascension and declination in. And I'd go back to Stellardoppy, just highlight the RA, copy, go here, Control V, and that'll convert, and then it'll convert it from into sexagesimal. Now let's have a look at the declination. We go back here. Here is the declination here. Copy, Control V, and just click out of that, and that should give us a decimal. So everybody still with us? Tom, you still there?
Yep, I'm here. Looking good.
Okay, all right, thank you. I hope you don't mind me asking. I just don't want to be talking into thin air.
Nope,
All
don't
right.
mind at all.
Okay, so there's maximum air mass is 1.6. The lunar separation is 30 degrees. We want to keep the moon well away from our star. I've said 30 degrees. And then here we come down with the visibility. Now, this date here, this is in universal time. This is the current date. If I go to, let's go, if I can go to new tab. Oh, favorites. If I go to the day-night world map, this is a map of the day-night of the Earth. So it's nice and sunny here in Australia. Oh, it is a sunny day, and it's nighttime over for you guys in North America, or those of you in North America. And you notice down here, there's got the universal time is Thursday, the 16th of October, 2025 at 2:23. And if we go to the Las Cumbres Observatory here, what have I done?
Just hit
Ah,
the back button. Just hit back.
okay, back. Yeah, it's around about the same time, and it gives you 24 hours ahead to start the observation and the end. So what this graph is telling you is that our star Dunlop 5 is visible at these observatories over the next day in this sort of time frame. And so it's visible here at Cerro Tolo is the observatory in Chile. Siding Springs is the the Australian Astronomical Observatory here in Siding Springs in New South Wales, about 6 hours north of me. And then we also have Sutherland, which is an observatory in South America. So hopefully one of those observatories will be able to pick up your observation. It might be cloudy in Chile, and then this all goes to a robot which assigns the observation. So if it's cloudy in Chile, then well, it might go to Siding Springs. If it's if it's clear in Chile, it'll try and do it there, and it'll move around trying to get in your observations there. So is that clear so far?
Yes, to me.
Okay.
I have
So,
I have a
yeah,
question.
yeah,
Like,
sure. Adriana,
so
yes.
yeah, so you said to keep like this thing called PKDN under 40,000. What does that mean?
PKDN is like that's a good question. Let me just have a look at the, here we are. It's the peak number of counts ADU data numbers in the object. So analog to digital units. It's it's the amount of light that gets converted into digital numbers. I'm not an expert. It maybe somebody else on the forum is an expert, but it's sort of a measure of how much light you're capturing.
Yeah, it depends on your camera you're using specifically. They'll give you a value for the maximum, what they call weld depth, which is the amount of ADUs you can actually accumulate before you saturate the detector. So keeping it down probably two-thirds or so of the maximum analog to digital units that the camera manufacturer tells you for that chip is your best bet.
Yeah, I'm a bit more liberal. I tend to just try and go up a bit higher, particularly when you've got faint stars. And we're going to come. I'll show you that in a moment. So let me just go back. How do I get
Yeah,
back?
but thank you.
Okay, let me just get back somehow. Can I move this?
Your right tab up at the top is the rest of it.
Okay, there we are. Yeah. Sorry, I've got something covering up my my screen. All right, so okay, you're ready to do your observation. Now, the most important thing you've got to do here, notice you've got a checklist here on the right. Each time you fill in information, it ticks it. So you want all of these green. Okay. Now, the next thing you need to do is press Save Draft. Okay, because that saves all this information. What I would suggest you do is review it. Let's go through it. So I'm calling this request Dunlop, Richard Jaworski Dunlop 5, RJ Dunlop 5, stemmed through astronomy research. That's the Boyce account. I'm going to take 20 pictures and the exposure time is going to be 0.26 seconds. The camera is fixed. I'm using a Bessel V filter. The name of the object is Dunlop 5. And here is its right ascension and declination. Stellar Doppler is very good. You'll find that you'll see in a moment the star will be centered. We want the air mass to be 1 point. Well, suppose we wanted even a shorter air mass, 1.3. Okay, 1.3. You can see here, you can actually set the air mass to a higher value, and so maybe get a better observation. The less air it's looking through, maybe the better the data will be. You've got the time here, and we've changed something there, so I'm going to save this draft. I'm going to save that draft. All right, so we're ready to go. I'm going to submit the request. You click Submit Request, and it says this request is going to take 3 minutes and 23 seconds of telescope time. Even though it's 0.26 seconds and 20 images, they have to change filters, move the telescope, and they include all of that in your time allocation. From the last course we did, Pat gave each of us, as individuals, 1 hour of LCO time to do your test images and your science images. So I think you should have enough time to do that. And I would click OK. I'm not going to click OK because I've already, and that will schedule your, well, actually, let's click OK because I can cancel it. Okay, here we go. And there's our request. All right. And we can look at the scheduling. It hasn't been scheduled. What about visibility? It's saying that these are our stars. Oh, looks like it's cloudy in Cerello Tirolo with the purple, but it's actually clear in wherever blue is. Sutherland is blue. That's in uh, South Africa. So you could probably get your observation. You can get your observation there. If we go back to home, there is my observation there. You can see it's one request, one pending, and when it's complete, this will become one there. So I'm going to cancel that one because I don't want to use up that time. So if you do want to cancel it, just go over here to this settings button and just say cancel. It can't be undone. So that's been cancelled. But let's go back the other night. I did some observations of Dunlop 5. And when you click, it says it's completed. Sorry. It'll have a green thing here saying it's completed. The visibility, yeah, it was clear at Chile and it took the pictures for me. And over here, we've got the data. All right. So when you get the data back, you're going to see raw and reduced. Raw data is the stuff that comes out of the camera, everything that comes out of the camera. Reduced data is the raw data that has been calibrated. So it's had various things applied to it so that you can use that data to analyze your stars. So it's had things like dark frames subtracted, bias frames applied, flat fielding, all these sort of things that occur. Now, what you need to save is the reduced. And it'll give you a picture of the star. Let's have a look here. So this is a long exposure, a slightly long exposure. Now let me just close that. Oh, I don't want to close everything. Okay. Okay. There it's so you've got your raw and reduced. Just click on reduction and click it again, and that'll give you all your reduced data. I only took 10 pictures because it was just for the class work. What you would do is highlight those pictures. There you go. This is your data that you're going to work with, and then you're going to download the selected. And these are going to be downloaded here as a zip file, and you just need to extract the file. And I'll do that for you now. Just takes a moment to download. So is everybody following me so far? Tom, can I ask you?
Yes, I
Adriana,
can follow you.
Maya, Shanza, are you following what I'm doing?
Yeah,
Yes.
sounds good to me.
Yeah, I am.
Okay, then, all right. So when I go down to my downloads, I'm going to have this file here, and I'm going to extract all this file, extract. And in it are my 5 pictures that have been, these are the reduced pictures. These are the ones that I can actually measure. Now I'm going to move a little bit, perhaps beyond my brief, and so this is your data that you're going to analyze. I'm going to move a little bit beyond my brief and talk about a program called Astro Image J, where this is the program that you're going to measure your double stars with. Okay, and I just want to show you a little bit about it. I'm not going to go into great detail because it's going to be a whole session about it, but I just want to show you what you're going to do with this data. Okay, you've got this data. What are you going to do with it? All right, let's go. Close these down. Okay, so let me just move this over here. So this program here is called Astro Image J. I'm just going to open it. Move my screen out the way. Hopefully you can see it there. And the first thing you want to do is update it to the daily build. You go, okay. You want to use the latest version, and it's constantly being updated. So you just update it. This will just take a few moments while it's updating the program, and then I'll start it again. So this will be the most up-to-date version of this program. As I say, I don't want to get into all the heavy details about how to use it. We're going to be doing this in a subsequent tutorial. I just want to show you what you're going to do after you've got this data. Let's just wait till it downloads. It closes after it downloads. Okay. All right, let's go here. Let's open. So this should be the latest version. Okay. So what we're going to do is go to File. We're going to import an image sequence. We're going to Browse. We're going to go to our downloads. Where's our downloads? Downloads. We're going to go to our LCO data on Dunlop 5. We're going to double click that and we're going to go select. And it says here that there are 5 pictures in there. So let's see what our 5 pictures were like, the ones that we took. You click OK. And there's our double star. I'm just using the scroll mouse, the scroll wheel of the mouse to highlight this. And if you click on this and then use your arrow across, these are the 5 images that were taken of Dunlop 5. Okay, 1, 2, 3, 4, 5. All right. So we're going to go back to the beginning. And we're going to do some measuring. We're actually going to measure these double stars. I just want to make sure I've got my calibrations correct. 5, 7, and 9. Sorry, 5. We'll go into this later on. I just want to show you where you're going to end up. All right. Don't stress out about all of this. I'll explain it. It will be explained. 9.
Do we need to download a software to do
Yeah, you'll
this?
need to download this software called Astro Image J. But
Okay.
it's present. It's present. There are links in the classwork. You'll be able to download it.
Okay, thank you.
Okay. The only thing that I would say is don't forget when you're doing this, click centroid apertures. Okay, and I'll show you why in a moment. So we'll say okay. All right. I'm going to measure some double stars. And I know that's the A component and that's the B component. Oh, by the way, this is reduced data. Do you notice it's got the RA and DEC already on it, the world coordinate systems on it. The field is orientated and it also shows you the size of the field as well. So all of this data, all of this has been done for you in the reduced data. So use reduced files, not raw files. Okay, so let's have a look here. I'm going to set the aperture here. Here's our A star. I'm going to the scroll mouse, sorry, on my mouse, the scroll wheel, I'm just going to press it down and then I'm going to drag that down here. And I've actually measured this double star. The distance
A right
between
click will
them.
do the same thing for you.
Yeah. The arc length is 11.36 arc seconds and the position angle is 184.3 degrees and the delta magnitude between the two stars is 0.19. So I'm actually going to do all 5 and just show you. Okay, so click on this, put an arrow across to the next one. Clear. Okay, this is the last star. I just want to show you when you click centroid apertures, you're wondering where the center of that is. Is it here or is it here? Is it here? The program will look at the curves and actually pick the center for you. So that is really helpful. For example, if I click over here and then click over here, do you see the crosses go to where the program thinks the maximum value for the star is? So that's very useful. You don't have to guess where the center of the star is. The program does that for you. And that's great for your measurements. All right, so we've measured 5 stars. Now let me just go over here, open this up. 1, 2, 3, 4, 5. There's our 5 stars. 5 measurements. Press results, summarize. What does that do? That actually gives you mean, standard deviation, and minimum and maximum values. I'm just going to save this. I don't want you guys to stress out about all these details. You'll become very familiar with this, but I would like to show you what your hard work in getting your observation is actually turns into. Okay, so we're going to save this as let's save it in downloads. We're going to call it table, I don't know, table 1, Dunlop 5. I've set it up so it saves it as a comma separated value. So CSV. So you will need a copy of Excel to study this. Let's just close that. I'm going to close this now, and then I'm going to go to downloads, now data, and there's our table. And notice here, I'm just going to tidy it up a little bit, just so we can see it, so we can see it a bit better. Okay. I would suggest getting rid of min and max. You don't really use it, but you will need your mean and standard deviation. So the mean arc length in seconds between the two stars here is 11.32587938 arc seconds. And the position angle is 184.4 degrees. How does that compare with stellar Doppler? Um, Let me just get that, move that up there. Okay. So the latest measurement for stellar Doppler is 11.321, and the separation, sorry, the position angle is 186 degrees. Ah, what have I done? Sorry, 184, 180, it's actually 184 degrees. That's incorrect. So it's 184.6 and 11.2. But that's what stellar Doppler says. So this is where you're going to be getting your measurements that you're going to be writing up. And there's your delta magnitude there. The other thing that you'll add in is standard error of the mean, but I don't want to go into that. All right, so don't save. Okay, so let me just stop there for a moment. Is everybody clear, first of all, about LCO, how to submit an observation, and then a little bit about how we turn that observation into data? Adriana, Maya, everybody, Shanza, what do you think?
Yeah, it makes,
You
makes
okay?
sense the process. Yeah, this pro I think I'll have to rewatch the video again once
Oh,
we
of
get to
course.
it. But
Yeah, yeah.
but yeah, I
I,
think the process is pretty like step by step.
It is, yeah. I've tried to make it as easy for you. Okay, guys, so we have done a binary star, a double. Remember, in our course, we have to choose either a known binary or a multiple star system. So now I'm going to move on to a multiple star system. And I'm just going to close Stellar Doppy. I'm going to close that, close that, close that, and close that. And what we're going to do now is we'll close Astro Image J. We're going to look at this multiple star system. It's called HJ1384. It's different to the one, as I said before, that we posted earlier because that's in Carina and not visible at the moment. You can't photograph it, but this one you can, and I've just photographed it. So this is a multiple star system. It's in Pegasus. It's called HJ1834. And it has these four component stars. There's the A star there, there's the B star there, there's the C star there, and there's the D star there. So let's go back to our old friend Stellar Doppy, and we'll start with that. So we go to Stellar Doppy, and we're going to HJ 1834. Search. So you can see that there are four components to this star. There's AB, AC, and AD. It's in Pegasus. Let's just go to the AB component. And you can find out information about these stars through Aladdin, or you can go to Simbad. And I'm just clicking on the A and B stars. It'll give you a little picture which looks exactly like the picture I just showed you. There we go there. See that? A, B, C, D, and there's the A star highlighted there in the green. There's the B star highlighted in the green. There's the C star highlighted in the green, and there's the D star highlighted in the green. Okay, so let's, and then you can click like on the A star here, and you can find out a whole lot of stuff about that star. Or you can also find the same thing in Aladdin as well, Okay, so we're going to try and take a picture of this star system. Now we have a problem here because one of the stars is quite faint. It's 13th magnitude. And this may be a problem with some of the multiple stars in that the brightness can vary quite a bit. You might have, A and B star might be quite bright, but the C and D stars might be a lot fainter. So that's something you're going to have to sort of wrestle with. I'll go through it with you in this example, and I've perhaps stretched the boundaries a little bit, but we'll see as we go along. Okay, so here we've got an 8.66 magnitude star, a 9.67 magnitude star, a 10.98 magnitude star, and a 12.9 magnitude star. So let's go, we're looking at AB. So what do? We go to LCO. As I said, normally it would ask you to log in and it would log you in. And now we're going to submit an observation. So we're going to call this, I'm just going to call it, sorry, RJ HJ 1834. Again, the proposal is STEM through astronomy research. Forget it, don't worry about these other things. We're going to take, well, between 12 and 20. Pat says 12, I usually do 20. We'll work out exposure time in a moment. This is a bit tricky, this one. We're going to use the Bessel V filter again. I quite like using that. We're going to call it HJ. HJ stands for John Herschel, son of William Herschel, very famous astronomer. And again, we get our RA and DEC from Stella Doppie. So here's our RA, copy, Control V. And then we've got our DEC. Okay. Sometimes when you copy and paste it that way, it doesn't like it. So I usually just put the bar there and just press delete. Maybe I'll copy over some other stuff from Stella Doppie. But yeah, if it works, it should give you the decimal numbers there. We want a air mass of at least 1.6. And we want the moon, at least 30 degrees away. But, if we have to, it could be 15 degrees. And now we've got to work out the exposure time. All right, now this one is tricky because we've got one star which has got quite a difference in magnitude. So what I usually do is get the brightest star, so 8.66. Now you may not have this problem with your multiple stars. They might be closer in brightness than this one, but this one's a challenge. All right, we're using a Bessel V filter. We want the air mass to be 1.6. The moon is sort of half going on new. And 8th magnitude is a fairly faint star. So let's start off with an exposure of, say, I don't know, 4 seconds. And we calculate. Well, at 4 seconds, the image is saturated there. Let's go a bit lower. No, still saturated. Okay, so at 3.88 seconds, it's 39,000. Just put another 8 there just for interest. Oh, okay. If I go up to 9, I think it'll be saturated. Yeah, so 3.8. So I'm really pushing things here and I'm getting the maximum before it saturates. And the reason why is because I have a very faint star. One of the components is very faint. And if I try and photograph that with with a longer exposure, the primary star is going to be just saturated. All right, so let's see what that happens. So 3.88. Let's have a look at the other stars. So there's one at 9.67. Oh, 15,000. That's not bad. That's pretty good. What's the next one? 10.98. 4,000, that's not great, but for me, it's acceptable. And then the problem star is going to be this 12.9. This is where we're going to run into problems. But I'll show you. It can work. See, we're only getting 752, whereas the 8.66 gives us 39,000. So there's a huge difference. So that star's going to be very, very faint. But let's see what happens when we do that on this pair. And as I just chose this pair because I was doing the other pair and I just realized that it wasn't visible and I had to find my a pair fairly quickly. So I chose this one. And it is challenging, but hopefully if you're doing multiple stars, then your magnitude differences may not be so great. All right, let's go to here and we'll say, so the exposure we decided was 3.88 seconds. 3.88. Okay. Once all your boxes are ticked green, you go down here and you can see that this star is available. If you want to have a lower air mass, you can actually make that 1.3 if you wanted to. And that gives you the visibility. So it's visible at McDonald Observatory in the States, Haleakala in Hawaii, and Tidi, which I think is in the Canary Islands. So over the next day, these are going to be visible. So the next thing you do after you've checked everything, okay, request name, stem. I'm going to do 20 images. There's my exposure, Bessel V filter. There's the RAN deck. I'm actually going to try and get 1.3 as the air mass. And for close double stars, oh, actually 1.6 is probably okay because these are wide. For very close double stars, you probably, the less air is better because you'll get maybe some better seeing. So the most important thing, remember, is to save your draft. Save draft. Have I forgotten something? So this is going to use 4 minutes and 35 seconds of telescope time. Are you sure you want to submit it? I'll say okay. And if I go here's the details of my observation. It hasn't been scheduled yet. Let me look at visibility. Oh, looks like it's visible at McDonald Observatory at Haleakala. Looks like there are two telescopes at Haleakala could do this, but looks like the Canary Islands is out of line because of weather. So hopefully one of these two telescopes will take that image. So I'm just going to go home and I'm just going to cancel that. Click. And if you make a mistake, just cancel it. Okay. But the other day, I actually took pictures of this object, and here it is here. All right. So I think I took. Let me have let me have a look at the data. Okay. So there's our star, our multiple star system. This is a longer exposure image, but you can see that all the four components are there. Let me just magnify that. A, B, C, and D are there. All right, remember you want the reduced data, not the raw data. How many did I take? 1, 2, 3, 4, 5, 6. Okay. So for each raw, there's going to be reduced. So I took 6 images. So click on reduction and you just want the reduced data. So we're going to, download the selected. 1, 2, 2, 3, 4, 5, 6. And I'm just going to clear that other one that I did. Sorry, just doing a bit of tidying up as we're going. Okay, let's go back here. Sorry, here we go. Okay, so I've chosen these ones, download the selected. So it's going to download these 6 images for me. Everybody still there with me?
Yes, indeed.
I haven't been talking to myself for the last half an hour.
No.
Okay. All right.
Can you point on your screen where your download indication is?
Just here.
Right.
Download in progress. And it should open up there. Okay, there it is done. So it comes as a zip file. If we go to if I go to downloads and then I just extract the data, it's a zip file, so extract. There's my 6 observations of this star. All right. So we're going to go now to see what they look like. So let me just close that. I'm just going to close that, put that down there, close that. I'm just going to go to Astro Image J. So file, import, image sequence. I'm going to browse, go to my downloads, select. I've got 6 images here, 6. I'm going to go OK. And there's 3 stars there. Let's have a look. You can make them brighter by changing the histogram here. So do you notice even though that that faint star, the faintest star only had like 900 digital units, it's actually still visible here and we can measure it. Okay. So there's our A star, there's our B star, there's our C star. Sorry, there's our A star, there's our B star, that's our C star, and that's our D star. Now I'm just going to measure these again. I'm going to use different apertures. So I'm going to go to set. I'm going to just change this. Don't need to tell you all about this at the moment. We're going to learn about this later on. But I just wanted you, again, to find out what are you going to do with your data. Remember, centroid apertures ticked. Press OK. Let's do some measuring. All right, we can measure A to B. There we are. Okay, clear. We can measure A to D. Yep, gives us our arc length, the position angle, delta magnitude, so we can clear that. What about this tough one, AC? Will it measure it for us? Well, if we'll give it a try. And it does. Even though it's faint, we were able to get. I'll see if I can magnify that. See, it's picked the center of what it thinks is the centroid there, of that star there, and it gives us an arc length, a position angle. Now, I'm really stretching things here. I know the delta magnitude is 5. You want to have delta magnitudes that are sort of no more than 2, but it can be hard. Pardon me, in multiple star systems to do that because they can vary a lot in brightness. So again, let's just measure this here, A to B. Next one, clear. 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 A to B. Okay, let's have a look at our results there. I've included the other one from the other one there. Sorry, let's just. It's included all my observations. So when I was measuring other things, it put them in the table as well. So what I'm going to do is I'm just going to start again.
For your measurement table.
Yeah. Okay. I'll just start. I'll just start again. Yep. So file, import, image sequence. It remembers what your last one was, so that's fine. That's going to go there. There's our stars there. Just use your scroll mouse. So 1, 2, 3, 4, 5, and 6. So just letting you know what these sort of apertures are. The inner circle is actually the star you're measuring. The next annulus outside is like a exclusion zone that you're not going to measure. And then the next annulus outside there is the background, which you're going to measure as the background. But we'll talk about that later on. So if you go and look at your table now, hopefully, yeah, we've got 6 stars there. Results, we're going to summarize these. We're going to save them, save as. Actually, you can actually, sorry, cancel. In your setup, you can, options, you can actually, file extension for tables is .csv, which is an Excel file. So I don't have to write Excel. I'll just save it. Save as table 1. HJ 181834. Okay. Let me just move that away. Save. So if I go down now to downloads, we'll see the data, table 1. There's my table. I'm just going to, this is just the way I do things. I usually get rid of min and max because we don't usually use those. But there's your arc length there for AB is 27.6 arc seconds. There's the standard deviation. The position angle is 174.1. So let's see how that compares. Oh, well, we can check that another time. Then delta magnitude is there. Okay. So that's a multiple star system that we've measured. I've pushed the boundaries a bit with that one. Hopefully, we won't have to go to those extremes, but it should be. Let me just close that there. Okay, let's go back. Come back to Earth. So okay, so let me just spread that out. So guys, are you clear from those 2 examples? Get an idea of how to do your observations with LCO. Delia, Jason, sorry, I'll just find out who's here.
Richard, I got it.
Okay, then, all right. Adriana, Shanza, did you, Valeria, did you get this sort of what I'm talking about?
Yes.
Yeah.
Yes, for the most part.
Okay, then, all right. Okay, let me just, I'm sharing my screen. There we go. I'll just speaker view. How do I? Oh, exit full screen. Here we are. Yeah. So in summary, we've got Dunlop 5. We've taken pictures of it with LCO, and we've analysed the data with Astro Image J, and found out how to do that. And then we've looked at a multiple star system here, and done something similar. Obviously, you'd have different tables for each of the A, B, A, C, and AD components of this star. And then you can look at the all the astronomical information about those stars, parallax, and things like that. So I'll leave it open to questions now. Let me just see who the participants are. Valeria, Shanza, Jason, Delia, Adriana. So look, perhaps I'll just open it up to questions. If you have any. Have any of you been in contact with your other team members?
Like this is kind of random, but this is Tashanse. Sorry, I don't know if I'm pronouncing it right. Did you get my Slack message?
Oh, I haven't checked Slack in like a couple of days. Let me check it right now. I'm sorry.
Okay, you're
Yeah.
good. It's okay. It's just like yeah, I sent you a message.
Okay.
Okay. So guys, so please check your Slack messages regularly. And so have a, keep your team member as like a good friend, that you text often and so you have good lines of communication. Have any of you decided where you're going, if you're going to use a known binary or a multiple star system, or are you still thinking about it? Okay, so Delia, you've decided on multiple star system. Okay, fantastic. Your team. Okay, yeah. Well, as I say, I'm always available if you want to message me on Slack if you have a problem. I'm very happy. Okay, so Jason's going to do a multi-star, and his team's going to do a multi-star system, but haven't chosen one yet. Yeah. Um, if you have an issue, please send me a message, and if I can help you, I will. Yeah. All right. Um, are there any other questions?
Thank you, Richard. That was real good.
Okay, all right. As I say, this is how I do it. The videos the video presentation it is slightly different, and like always, there's more than one way to do something, and still get the correct methodology. But as I just wanted to demonstrate, this is how I've been doing it and how I've been getting my data. I think the next thing we'll probably need to do is talk about Astro Image J, how to do the things that I've done here, but also how to um, decide on what apertures you're using when you're measuring stars. Um, Sorry, just got a message there. So yeah, that's something we can go into when in another tutorial, and I'll talk to Pat about that. But please, if you're having an issue or a question, then please contact me, and I'll be happy to help. Um, so
Do have
okay,
a question.
yeah, yes, Adriana,
Sorry.
please. Yeah, sure.
Okay. Where can we submit our payments?
Oh, that's a good question. You have to ask Pat about that. I know there's been a problem with that, so please contact
Yeah.
Pat directly. I'll send him a message as well.
I got an
And
email for it. That's where I submit my
oh,
payments,
okay.
like
Thank
it's on
Yeah,
email.
normally it's done through PayPal. Um, uh,
Okay.
Normally it's done through PayPal, but normally Pat has sent out invoices to people for payment. Just check your email, but if you haven't had a invoice, then please either send Pat a direct message on Slack, might be the easiest, or send him an email.
Great. Thank you.
Okay, then. All right. Um, Well, if nobody has any other questions, I think I might let me just stop sharing, and I might just